Matrices Introduction. Objectives. Definition of matrices. Types of matrices. Matrices are nothing but the rectangular arrangement of numbers, expressions, and symbols which are arranged in columns and rows. Matrices finds many applications in scientific fields and physics-related applications. Matrices are applied and the study of electrical circuits, quantum mechanisms, and optics. In computer-based applications, matrices play a wider role in the projection of three-dimensional image into two-dimensional screen and creating the realistic swinging motions. One of the most important usages of matrices in computer-side applications are encrypted of message codes. In robotics and automation, matrices are the basic component for the robot movements. The inputs for controlling robots are obtained based on the calculations from the matrices, and these are very accurate movements. While analyzing the situations related to problem statements of robotic movements, we come across the need of various properties and illustration based on matrices and determinants. Let's learn few illustrations related to 3x3 matrices. Definition. A set of mn numbers, real or imaginary, arranged in the form of rectangular array of m rows, each row consisting of an ordered set of n numbers is called an m by n matrix. A equal to matrix A11, A12, and so on, A1j, and so on, AMN. In a compact form, the above matrix is represented by A is equal to matrix Aij of order m by n. 1 is less than or equals to I is less than or equals to m. 1 is less than or equals to j is less than or equals to n. Or A is equal to matrix Aij. The numbers A11, A22, etc. are known as the elements of the matrix A. The element Aij in the matrix A belongs to ith row and jth column. Example: matrix A is equal to 0, 1, 2, minus 1, minus 4, minus 7, 9, 3, 5, 6, 2, 9 is the matrix having 4 rows and 3 columns. So, it is a matrix of order 4 by 3. Also, A32 is equal to 3, A43 is equal to minus 9. Various types of matrices. Rectangular matrix. If the number of rows is not equal to the number of columns, then the matrix is called a rectangular matrix. Example: matrix 2, 5, 7, 3, 4, minus 9, order of 3 by 2. Square matrix. A matrix in which the number of rows is equal to the number of columns is called a square matrix. Example: matrix 2, 3, 4, 0, 1, 2, minus 1, 1, 0. An n by n square matrix is also called a square matrix of order n. Thus, A is equal to matrix Aij, order of n by n. Row matrix. A matrix having only one row is called a row matrix or a row vector. Example: matrix A is equal to 1, 5, 7, minus 9 of order 1 by 4. Column matrix. A matrix having only one column is called a column matrix or a column vector. Example: matrix minus 2, 0, minus 3, 0, 5, order of 5 by 1. Null matrix or zero matrix. A matrix in which each element is 0 is called a null matrix or a zero matrix. Example: matrix all elements are 0, It is a null matrix of order 4 by 3. Diagonal matrix. In a square matrix, if each non-diagonal element is equal to 0, then the square matrix is called a diagonal matrix. A square matrix A is equal to matrix Aij, order of n by n, is called diagonal matrix. Then Aij is equal to 0 for I not equal to 0. Example, A equals to 1, 0, 0, 0, 2, 0, 0, 0, 3. Is third order diagonal matrix, denoted by diagonal of diagonal matrix 1, 2, 3? Note, matrix D1, 0, 0, 0, D2, 0, 0, 0, D3 is equal to diagonal matrix D1, D2, D3. Unit matrix or identity matrix. In a square matrix, if each non-diagonal element is equal to 0 and each diagonal element is equal to 1, then that matrix is called a unit matrix or identity matrix. Unit matrix of order n is denoted by In. In is equal to matrix Aij, order of n by b, where Aij is equal to 1 if I equals to j is equal to 0 if I is not equal to j. Example, I3 equals to 1, 0, 0, 0, 1, 0, 0, 0, 1. I2 is equal to matrix 1, 0, 0, 1. Summary.